My name is Pontus Rydin. I am the Chief Evangelist for a product called Wavefront. No, this is not going to be a product pitch. It will feature some of our products, but we'll tell you, how you can use alternatives as well, right? With me today, I have Gordana, who is product marketing, right?
Yes. Mm-hmm.
And the most important person here is Hristo, because he is the guy who actually writes code, or actually does something interesting. The rest of us are just like talkers, right? What we're going to talk about today is about observability. So all of a sudden, monitoring is no longer cool to say, so we need to say observability. But that's not really what observability is. To me, observability is a feature of software, right? Something becomes observable and when it has observability. It means basically that all these little things, you can hook up to them and you can ask them how they feel, they can report to you how they feel, and it can do that on a pretty detailed level. So we're going to go through how you can do that with things running on Cloud Foundry. Hristo here is going to go through a bunch of best practices on how they use various tools in the product that he's working with. And yes, there's going to be code, so yeah, stay for that. So why don't we get started?
Okay, so I will give a brief overview, and let me start with current situation that more and more cloud-native applications are microservices based. They are running in containers and orchestrated with Kubernetes. And we have major benefits in getting in scale and flexibility, but at the same time, there are so many moving parts, and it's very hard for developers and operators, DevOps, to do proper understanding, monitoring, and troubleshooting of the system from infrastructure going up to the applications. Therefore, solutions that abstracting actually infrastructure like Kubernetes on or a pivotal platform are helping DevOps and developers in order to onboard as many projects in a day and to provide resources in very efficient way. So many engineering teams are running many instances of applications. They are doing fast code deploys. They are doing easy rollovers, and all that in the sense of the culture. You build it, you run it, you own it. That kind of culture and environment requires deep understanding and deep observability of the platform as well. And Pivotal Platform, for instance, has a fire hose that actually literally give explosion of metrics. And you need observability tool that can make sense. And Pontus actually did a small installation of PCF, and this is how the fire hose look like. You cannot make any sense of it. Therefore, when you're looking for application tool, you want to make sense of the explosion of the data, you want to make sense of the dynamism of the data that's constantly changing, like your containers, and at the same time, you want to be able to communicate and collaborate with the different part of teams so that you don't finger pointing and it can easily solve the issue and not allow it to become an accident and impact your users. So when you're looking for the modern observability tool, you're looking for a tool that can give you information from the infrastructure or any of your cloud, AWS, Azure, GCP, or a combination of those. You want to go up the full stack, going through the Kubernetes, going through the health and performance of your clusters, nodes, pods, containers, namespaces, and connect all these layers with applications and business metrics on the top. And you want to be able to customize everything. So this is just an example that one of our customers using, actually Skyline, and Hristo will demo it, is that you are taking the metrics from your platform. You want to take metrics instrumenting your code, Micrometer IO or StatsD or Drop Wizard. You want to have different DevOps tools integrated together. You want to be able to alert using PagerDuty or Slack or VictorOps. And then when you gather all this data, you want to be able to slice and dice, to aggregate, to filter, and present it in one platform. And then you want that automated. And at the same time, you want to be able to customize it, because you want every team has their own tweaks and dashboard they want particularly to follow. And when you're doing that, you want to have metrics data. Metrics data is very compact, and it's useful for alerting. You want to create alerts. You want to have very powerful, flexible analytics as well. And then you want to have histograms as well. Histograms are good for high velocity data. When you have high velocity data, you can, with histograms, see should you immediately focus on that problem, or you can wait a little bit. Also, you're not losing your information through averaging or aggregation, so you have that information. And finally, you want to have distributed tracing. Distributed tracing allows you to follow your request from the beginning to the end to figure out where is the bottleneck, where is the most of time that's spent in your request, and can you optimize it. And when you're doing distributed tracing, there are some best practices that you should follow up on. And first, you want to look for the open census, open tracing solution. So if you, in modern application like today, you have so many third parties services, you want to be able to communicate through those services no matter what framework they are using or language. You want to ponder, would you want to go open source or enterprise? You want to go through the effort you have to invest, or the scale or high availability that you have to deal with. And then start slowly and then instrument big. And if there is a tool that can help you and do instrumentation for you, even better. So distributed tracing, metrics, you want to have as well histograms. You want to have events as well, because they influence what's happening in your system. And then regarding open source integrations, the more the merrier. And here you can see some of them, like Prometheus or Jaeger. And finally, before handing to Pontus for live demo, again, real-time enterprise end-to-end visibility is very important in order to effectively troubleshoot. And if you have analytics, very powerful to AI, ML-based analytics to proactively alert you and give you actions, what to do and how to deal with the incident, that's very, very useful. Yeah. Okay.
Yeah, I'm going to hook this up. But before I hook up the demo, I kind of just wanted to get a show of hands. Like, how many of you guys are actually actively using some kind of distributed tracing? What? Distributed tracing. Oh. Yeah, okay, so about maybe a handful, maybe 2 handfuls, right? So how many of you don't know what distributed tracing is? Okay. Yeah. So I mean, the distributed tracing is basically just like collecting information about the transaction, where it's been, how it went, if you got an error, how long it took, how many times you've been to that point, and then being able to actually pull out one of those distributed traces and kind of say, okay, this is what happened, and that's what a bottleneck is. So it's like that kind of thing, right? So it's been a thing for a long time, but it's becoming more and more important with microservices because you have these really complex ecosystems, right? Gordana also talked about histograms, and how many of you guys know why histograms are so important when you're monitoring like high frequency data? Yeah, exactly, right? So if you don't mind, so let's say you have a service that's being called 10,000 times a second or 10,000 times a minute. 10,000 times a minute, that's kind of a moderately used service, right? I mean, we have things that are called, where I work, we have things that are called 1 million times per second. But let's say 10,000 times per minute, right? And you collect every time it's called, But you don't want to enter one times data point in the database for every single call, because if you have 10,000 a second, that's going to be a problem. You're going to fill your database, right? So what do? You take an average, sure. But then you miss all the outliers, and the outliers are the ones that are interesting, right? So now you have this problem, like, do I save every single data point every single time that method is called, or do I average? None of them is a good alternative, right? So instead, you can remember the stats course most of us took in school, right? That you can actually have a distribution of, you can look at a histogram. So you go, how many took 1 second, how many took 2 seconds, so on and so forth, right? And you build that histogram of the distribution of how long something took. And now you can actually store that in the database. And math shows us that if you have that, you can reconstruct everything, like percentiles, like, hey, I want to see the 95th percentile of slowest calls and things like that. That's why these histograms are so important. So when you're choosing a monitoring tool, and you can go down, there's at least a handful of them downstairs, right? When you're choosing that, histograms is a really, really important feature. Many of them have that, but that's an important feature, because otherwise, when you're doing this distributed tracing, your data is going to get lost. It's going to get lost and averaged out. That's kind of why that is important. Now, let's see if we're lucky. All right, so this is saying PCF all over the place. I've been told very strictly I'm supposed to say pivotal platform. So every time I say PCF, I actually mean pivotal platform, because that's the new name for it, right? So what do you need when you monitor something like that? Well, pivotal platform is really complex. It has a bunch of different components to it, and they all interact. And to make matters worse, that actually runs on infrastructure. You may think that things are serverless, but they're not. There's like actually hardware and servers and stuff, believe it or not, right? So one of the first things you want to know is, like, is my PCF environment healthy overall, right? So you want to get just some basic red-green kind of monitoring, right? And you want to see things like available memory, CPU, how much disk space you have left, those kinds of things, right? This is typically like somebody who's operating pivotal platform. They have this as their knock view, or whatever you want to call it, right? That's what they're staring at. And when something here goes red, well, they need to do something. But this is still a pretty simplistic view of the world. Like, this is very much like the operator centric. Of course, what we can do is we can start drilling down into applications. So we can get a breakdown of all our applications that run on top of our platform. And that's important, because you can see now, if an application is misbehaving, you can see now, you can get an overview. Why is it misbehaving? Is it misbehaving because of high CPU usage? Is it misbehaving because it's running out of some other resource? Things like that. So this is kind of like the first level of drill down, right? Still at a pretty high level, still pretty basic type of monitoring you're doing. But it's very useful, obviously, very, very crucial that we have it. We can do other things like, what do you have? Like disk percent used, yeah, that kind of stuff, right? Now, as I said, unfortunately, stuff runs on infrastructure. So the next level is, you need a tool that can correlate what's going on in PCF, what's going on in your application, to the actual infrastructure it's running on. And in this day and age, people tend to forget about that, because, oh yeah, we're on cloud, or we run on some magic thing, right? That's serverless, whatever. I've heard it all, right? But some of you nod yeah in agreement. And you're probably the people who have been, having to chase things. My application is running just fine. There's nothing wrong with the code. And you actually have to follow this chain. I have an anecdote from a big company that said the fact that they had a tool that could do that saved them about 2 weeks of troubleshooting, because it's just like random looking through logs or what have you, right? So you definitely need that. But you need a little bit more. And hopefully that's the right one. Yep, it is. You need a tool that could automatically correlate things. And this is kind of a silly example, because this is an application I made behave in a strange way. But this is an application that has performance spikes. Once every, whatever it is, minute or something like that, it spikes. The response time spikes up, and yeah, we don't like that at all. So what are we going to do about that? Well, one thing we can do is we can, of course, look through all the components manually. And in fact, that's what we can do here. Like, I can pick an application and I can say, hey, which VM does that application. LoadGen is my application, very interesting. Right? LoadGen runs on that VM and it runs on that host, and all of a sudden I basically tracked it all the way down to the hardware. That's easy to do. That's table stakes, right? But when it gets cool is you can say, hey, I got this spikiness. Let's do a mathematical correlation with that spikiness and some random metric in the environment. So I want to say, is there anything in my environment, CPU utilization, memory utilization, whatever it might be, that exhibits the same kind of spikiness, right? So your tool should be able to do that, to be able to do that kind of a correlation. And in this case, what we do is like, yeah, we're coming up with like 5 Diego cells, okay. Now, what are those Diego cells? What do they have in common, right? Well, what they have in common is that they run on one specific physical host. Okay. So instead of having to click through here, this actually did a machine correlation for that. So it was able to find that out. Automatically. And the reason it says no data on weighted memory correlations, there was no correlation. This is not memory bound, it's CPU bound, right? So it showed us right away what the problem was. Yes, our Diego cells are CPU bound. Diego cells is the stuff that actually runs my code. So yeah, my code needs more CPU. Cool. Now I know how to fix that. But of course, it doesn't really end there, right? Because it might be, thought I had a better one here. Let's go back here. One of the things I probably want to do is I want to look at the performance on my application from a user point of view or from the caller point of view, whatever it is. So here's my little web shop application. If you've ever seen a demo that we give, we always use this little t-shirt shop. It was on the main stage at VMware, a bunch of other things. Anyway, problem I'm having is that the experience that my users are having is going from like 0.3 seconds to 0.7 seconds response time. And I really need to know why that is. I kind of a bit nervous about that, right? Okay, so this is good, right? This is, at least it's telling me that. It's telling me that that's errors are spiking up a little bit. Okay. It's also telling me this seems to be the slowest service in my mess of microservices, order search. Okay. All right, so of course what I need to do is I need to be able to go from here, go from the metrics-oriented world into the tracing world, right? These are the distributed traces we talked about, right? And now I can see that, that's that specific function in that specific microservice that's causing this, right? So this is, when you're doing these kinds of things, this is something you need. You need that kind of stuff. You're also going to need custom metrics that Hristo is going to talk a lot about here. But yeah, this is kind of the standard stuff. And finally, again, you need this type of correlation here. So let's fast forward. I was troubleshooting that thing that I had this increase in latency. And I did find that something as pricing service was called. And I happen to know that my pricing service is doing a lot of database accesses. So I'm thinking, okay, might be a slow database statement. So why don't I take, because my monitoring tool, Wavefront in this case, can do that. It can get me all the SQL statements that take longer than 800 milliseconds to execute. Well, that didn't tell me much, right? That's a mess because I have a gazillion SQL statements in this one. What I need to be able to do is I need to be able to do a correlation, right? So hopefully this loads rather quickly. Wow. It's probably because I've been changing resolution back and forth there. There you go. So what I did was I took it from showing all the SQL statements to actually only showing the ones that are correlated. Correlated with what? The ones that are correlated with my performance there, right? So why is this important, right? Because sometimes you don't really know all the dependencies. Yeah, you can show that fancy dependency map we just had on the previous slide. But there are times and places where that gets too complicated. The map gets too difficult. We don't really know we can't discover all the dependencies. What you need to do in those cases is take the statistical approach again. Hey, I think my problem is somewhere in there, in all those SQL statements. That's my haystack. Now I need to find the needle. The needle in the haystack is that one SQL statement that has an issue. And so what I do is I use math and I correlate, and I can say, hey, it's select price from yada yada, blah, blah, blah. And of course, you can go on and correlate and say, hey, yeah, it's the I/O weight, and it actually has to do with the latency on one of my drives, and so on and so forth. And yeah, you can drill down there. So these are kind of some of the capabilities that your monitoring system for something like an application running on Pivotal platform needs to have. So I work for Wavefront. You're welcome to check it out downstairs. There's a bunch of others as well that do similar things, right? But this is kind of where the state of the art of the monitor market is going to deal with this microservices observability. So that was me doing my little spiel, showing what we think a tool should do. Let's talk to a guy who's actually doing it for real.
Yeah.
So,
thank you, Pontus.
yeah, no problem.
Let's switch laptops.
Yeah. That switch went better than I thought.
So let me talk more about Skyline and explain what Skyline is. So Skyline is a VMware product that aims to change how VMware does support to customers from reactive type of support to proactive type of support. So it has nothing to do with collecting metrics data and anything like this and targeting any time series database. It's a product that enhances support. Let me start from the beginning. So it's a relatively young product. It's about 2 years since we made the initial release. It's really cloud native. We built it this way. So before I proceed, can you tell me how many of you build cloud native applications? Okay, good. Year and a half ago when we started, we were at about, I don't know, a few hundred customers. Right now we are 5,000 customers. And our targets are quite aggressive. As part of the support that VMware provides, it's a complementing product. It comes for free, so we want really to scale up to, I don't know, 50,000 till end of next year. So when I said that, and when I go back 1 year ago, we really had to put some key drivers for us. So when we were at the point where we have to make a lot of decisions. So we decided not to deal with any infrastructure. This is why we decided to go on a PaaS solution. So engineering teams had to do their core business, which is developing and adding value to the product itself. We also realized that we should not be bound to a particular platform. We should be able to port our code anywhere. So this is why we decided to build our applications using Docker images. So today we are using Pivotal platform. Tomorrow, who knows, it depends on our needs, our scalability. We have to really have the flexibility. We really go after microservice architecture. That's a must in nowadays, more or less. So maybe the next extension would be mesh. Let's see. We really have to be able, when we deploy our code in production, to be able to determine how it works. Really, we should know every piece of bit. We are leaning towards heavy metric data. This let us know, does it behave well? Does the service degrades? So what problems it might suffer? So this is really important for us. And preferably there should be just one tool where we go and be able to check all the data that we need to operate successfully that services. We just need one tool. We don't want SRE team to go here, engineering team to go there. Okay, we look this, you look that. So where is the problem? That's something that we don't want to. For sure, dev owns the quality. This was the decision we made back then. And we really have to be able to deliver on production on a daily basis. So these were the key drivers a year and a half ago that we stand upon and drive us to the point we are here. So yeah, we use Pivotal platform. We use Wavefront as a tool that combines metrics from various sources and enables us to build integrated dashboards that enables us to measure everything, and monitor everything. So let me lean a little bit more on the platform and the components, how it looks like in our world. So you know that in the cloud and in cloud native applications, it can be pretty nasty and pretty bad. So we use 2 data centers. We deploy each of our services in 2 data centers. So we are aiming for high availability and at the same time load balancing. So last year we were in a situation where one of our data centers went down. So we really faced a small downtime till our DNS basically detects that failure and redirects the traffic, start the resolution to the other data center instead of load balancing fashion. So we also lean and use Spring. Yeah, Spring Cloud, Spring Boot. You can see the green box, which is the PCF foundation itself. And even then, when you have a lot of your services there, still you have a lot of dependencies. You can consume services coming from the marketplace, like Redis, like Rabbit, like MariaDB, like Eureka, for sure. You do a service discovery, that's a must. And also you might have external dependencies. You might have services that are outside your environment. Yeah, they might be anywhere, but you depend on them, you have to fetch data. So you have to have a way also to monitor that and know, does it work well? Also, you might have any storages or any other services that are outside marketplace itself. So maybe they do one replication because they are a cluster. So when you're doing a load balanced request, they might flip from one data center to another, and still the customer experience should be the same, right? So this is how it looks like. We use Java, Spring Boot, Spring Cloud, and Micrometer IO for capturing all the metrics data, which basically comes to Actuator. It fetches a lot of data from Actuator. And when you observe your services, you have to be able to correlate between my application performance, between my Redis performance or Rabbit performance, between my data store, which in our case is MongoDB, and even your external services. So all these you have to have the way to monitor in one single view. And this one single view should be unified among all the teams, SRE, IT, engineers, developers. So you have the same understanding over the data, and you can easily pinpoint where the problem is. So let me go to the demo itself, and I would start with something really simple in the beginning, and would start with a simple service, which is the Skyline scheduler. I'm going to show a demo how we actually did this. Okay, let me change the duplicates. Okay, good. So what we see here is just a single service. This is a dashboard built especially for a single service. So each of our services comes with a single dashboard. These are common metrics we send and we emit and we build here. So if I go back to the slide and the previous slide, and I'm going to revert, in a microservice you have API gateways, and some of your traffic might land into the external gateway, which permits only a certain type of traffic and allows only to certain services beneath. And there might be an internal traffic where it's designated for your private environment and provides access to far more rich service set. And also the services between the different data centers may directly communicate between each other using a VPN, IPsec strategy, whatever. But services also communicate between themselves. So we have to have a way to measure all the traffic that pass through external gateways, internal gateways, between the services, from services to different other Redis or MongoDB, whatever. So this is what Pontus presented as a distributed trace, and it really nails that down. So in here, what we see is a dashboard that captures, as I said, just a single service. So we also extended the concepts, and as a developer, we look at getting more things out of the box. We try to put really less code and get as much as possible. But also, we realized that we need to put some events on our own, like, okay, did we do a deployment of that service? Let's put it on the dashboard. How many exceptions this service throw? Let's put it on the dashboard. So this is what you see here on the first two charts. So how many deployments happened for that service in the last 24 hours? How many exceptions occurred? So that's valuable information. And when we scroll down, you can see that the traffic that comes through our gateway. So basically, this service is really with no traffic that comes through the internal gateway, but really goes on the external gateway. So all that traffic is coming from our on-premise appliances that collects a lot of data from the customer environment and send it home. So you can see how this looks like. Of course, memory CPU utilization, that's a must. And when you scroll down, you can really understand the value here. So breakdown per status code, that's really nice. So you know how many of your were successful, how many are not, what are the latencies, and you can see that we have a lot of instances here. we have approximately 60 instances of services. So this metrics or this gateway request pass-through joins the metrics from the internal and external gateway. And beneath we have just the traffic that is between the services. So we know how much of that is coming between services communicating directly with each other and what is the success rate here. This is just the count, per status code. We can see also the latencies, and it's quite interesting. There are some outliers, as Pontus mentioned here, and these outliers produced 409, which is conflict. So even deep, we can tell which exact endpoints were called, right? So I know that this really consumes a lot, 1,000 something requests. Okay, maybe it's even higher. And let's see once again the latency. So as I said, we deploy, let's continue down, sorry. So we have PCF related services. This service consumes Redis, so we can see how Redis behave, how much memory we sized and we devoted to this service. So it's 2 gigabyte Redis instance, and we can see how the connections are utilized, how many connections from the applications are established to the Redis. Also, we can see the number of operations done upon the Redis keys. So it's any kind of operation. It may be get key, put key, whatever is available there. So also the input and the output KBs that went to that instance. So you can see how easily we can trace from the application to business logic down to your Redis or RabbitMQ instance you're consuming in PCF. Okay, so far so good. Let's examine another service, which is Heartbeat, and it's a similar dashboard, but right now I would like to do a little bit more digging here, because I know currently we have some issue, and I want to walk you through how easily we can discover that issue. So let's just scroll down a little bit and go to the latency request per endpoint. So you can see there are quite some outliers here that, let me just zoom this one and sync. Come on. Okay, you see 8 minutes. That is intolerable, and it ended up as 500. So this timed out really seriously. Okay, the exception is uncategorized MongoDB exception. So that's interesting how Mongo gave up here. Let's try to. There are no deployments done for this service within the last 4 hours, I see. Okay, that's good. So there is no code change introduced. Let's just filter out something that, just failed. Okay, good. And let's do a little bit more digging, and I'll just collapse those. I don't want to scroll back and forth that much. So let's right now try to filter per data center. Okay, let's see what's happening in one of our data centers. Okay, there are some failures, but really they are in milliseconds, so okay, let's check the other data center. Okay, now there it is, uncategorized MongoDB exception. So what will be my next step? I have to really understand what's happening and how we landed here. I know this is related just to the one data center, right? And as I showed, we use data store that is clustered with a couple of nodes in one data center and in the other data center. So some of them are replica set. So maybe something is happening there with that node in WDC data center. So this is once again the same distributed trace that view that Pontus presented, and in here. This is the same service. You can see in the last 24 hours how many successful requests, 12 million requests for GET operations, and et cetera, and few exceptions. So something went bad. Okay, let me try to right now align among the same window. It's today, and it's, okay, let me just focus on this one, make it a little bit more narrow. Okay, it's 410, 415, 210 to 15. And it is today. Okay. Okay. It's okay. Is it the same timeline? Okay, it looks like the same. Let's load the distributed trace and let's see how this looks like. It might take a while. Okay, yeah, so most of what you see right now comes from Micrometer and Spring Boot Actuator. So those two glue very well together. So let's see, you can see how this distributed trace looks like. And this inventory service basically is not ours. It's from another team that develops also microservices that consumes our services. So you can see that this is an internal, goes through our Skyline internal gateway. But they also use the same Wavefront tenant and the distributed traces. So this is why it appears here as part of this trace extension. So you can see the trace, how it looks like, and somewhere, I guess, okay, it's 164 seconds. Well, that is quite an operation. Most likely, there is some exception. Okay. And it is a long trace. And whoever owns that service should know why that is behaving in this way. Okay. Maybe that was not the proper exception. Okay. It would take me a while till I found the exact exception, but you can see the Mongo statement. You can see exactly what Mongo statement timed out and led to that 700 seconds. And then we already contact IT, and they are in pursuit of the logs in the MongoDB cluster to try to understand why this replica set behaves unexpected in this way. So right now, let me jump to a little bit of code sharing and tell you how easy it is to really instrument all that and send all that metrics to that particular Wavefront tenant. So as I said, we use API gateway. We have chosen Zoo. We're on the Netflix stack right now. Maybe in the future we will change to Spring Cloud Gateway. We've tested this for our use case in the beginning of the year, and we saw no benefits back then, maybe a little bit more trouble because it's reactive and it gives us some out-of-memory exceptions and buffer overflows that was not quite expected for us. So back then we gave up. And we also were able to implement some of the pre-filters and post-filters. So for those of you who know Zoo and use Zoo, know that it's quite powerful and it's open. You can hook up pre-filters, you can hook post filters, and we use exactly this functionality. So we really try to build common libraries that can be reused in each of our services. So we just do it once, and whoever wants can consume that. So this is enable Zoom metrics. This is an annotation, and this is the default metric name that is provided. So you can override this if you want, but this is how it goes if you only put this annotation on your application. So the pre-filter is quite simple, and the idea is to just grab the request context and set the current time when the request landed in the Zoo API gateway. So API gateway, when making a decision to where it should route the request, this might be a complex logic, but you want to know where this request goes to, right? Zoo does not really tap into the parameters at that point of time, so you don't have access to the full path. You can get the full path, but it's really hard to sanitize because in the path there might be a lot of values that would appear on your dashboards as really separate types of metrics or tags compared to just single one where maybe in the path you have a customer ID. So this is why we avoid capturing the path in the Zoo API gateway. So we capture the time, and of course, when it comes to the post filter, when this request was routed to the application did its logic and responded back with the response. So the same context you can hook into it, and this is what we are doing here. So Of course, we use the registry method, and I'll jump after that for the registry method, how we enable the registry method. For those who have used the Micrometer IO, you would know that there is a registry concept. So there are a lot of variety of registers and registry methods, and one of those is Wavefront registry method, and there are other registry methods for example, hooking with Grafana. So in here, in the run, we grab the context, we fetch the status code. Also, we read when the initial request accepted that. So we grab that from the context itself. Okay, if there is some failure, I don't know, we put an info, or it might be error. Then we measure how much time it took for the whole request to complete. So it's entering the request, doing all the logic, receiving the response. We measure this. We don't measure an individual level here. And then we get the metric. So it's a little bit of a utility method that builds different metrics depending on the target service. So Zoo talks with your service discovery. It grabs the service that is responsible for that path and would redirect the request there. So we build different tags for this. And this is how we measure and how we capture. So all these you can see is 3 classes, really simple, and they're Spring Boot. So you can easily just, when you spin up your Zoo API gateway, you just annotate your application and boom, the metrics are there. Not yet, they would be. So when we talk about sending metrics to Wavefront, somehow your application should know where it should send in metrics. That this is because it's Micrometer IO, it should know that you want to use Wavefront. So this is why you have to build a component, of course, that provides the registry method. And Wavefront registry method is an interface, of course, and it should be implemented here. So we build our own, but we have to inject the configuration for the bean. So this is why you use here the configuration, get configuration here. And we read from the environmental variables that we hook in our CI/CD. So for each of our application during the deployment CI/CD phase is instructed where the Wavefront, what is the URL, what is the key, etc., etc. So these all come here, and is injected to your application, so it knows where it should send its metrics to. And we also would like, because we realize that we can deploy our components, our applications in development environment, in staging environment, in production environment, in different data centers, so we would like to know where the source is. So this is why we extend and put common tags like the organization, like the space. So organization is a concept of PCF, so it represents our team and our applications, and the space we use as either development or staging in different environments. So far, so good. So we also can easily instrument any JVM metrics, and once again, this comes as a component. We auto-wire the registry, and as a post construct, we really bind a JVM memory and GC metrics and processor and threads and all of that. So this becomes available. Of course, we also enable the tracing. So this comes with that really simple bit of code. And we use SDK, so it's the Wavefront SDK and the open tracing for that. So we really spin our application. Once again, we use our space to define the cluster, which determines our environment, and the shard comes with our data center. So these are predefined tags you can use in the Wavefront. So for the trace itself, we exclude the JVM metrics because there would be an overlap, and there is no need to collect the same data again and send it twice. So this is why we exclude the JVM metrics, and that's it. So these are the pieces of code that are packed into a single jar that is being distributed with each of our applications. So this is how we easily emit all of that to Wavefront and being able to monitor all that. So I still have some time. And I would like to show a little bit more complex now. So when you look from a single service, it's easy. It's relatively small, and you can capture all that. But what happens when you come to a really more complex functionality, which involves a lot of moving parts? And at some point, we come to the conclusion that technical-only metrics, they're helpful. You can use them to drill down, but this does not mean that you really understand the end-to-end behavior of the functionality. And this functionality can be quite complex. In our use case here, what you see in the screen, it's on-premise appliance that sends data that goes being ingested, then it's being analyzed, and then it's being exported for, really provided for presentation to a customer. So we have an SLAs, yeah. So in here, we had to pick one single metric that tell us, are we in SLA? And we produce two different kinds of reports when we analyze the customer environments. One is the so-called inventory report, which really tells you how your environment looks like. So if you go into a vSphere, for example, you know there is data centers and there is clusters and workloads and all of that. And we do this for a variety of products, of course. So, and the findings report really does all the scanning of your environment. Is your environment misconfigured? Does it follows the best practices? So are there any security vulnerabilities in your environment and all of that? And you can imagine that being able to move from a few thousand to a few hundred to 5,000 and for the next year really beyond requires us or enforces us to really be able to fast make decisions, being able to scale applications and really understood where the bottleneck is. So these metrics really depicts what is the percent of the customers that are in SLA, and each report has an SLA. I have to produce every 12 hours a new report for each and every customer when it comes to inventory type report, and for the OSR reports or the finding reports it's once every 24 hours. And the whole functionality spans from on-premise appliance to a lot of cloud services. So you can see a little bit. So you know that picking a tool that collects all your metrics should also have some kind of alerting capability. So when something goes out of the rails, you are immediately alerted, and both the SREs and the developers have the same understanding. So let's see how things look like. And within the last 24 hours, here the window is 24 hours, you see that we have created approximately 12,000 inventory reports, and 12,000 something were produced. Because this is a moving window, this is why the completed might be a little bit more than created, just because the creation happened before the window itself, the window we are looking at. And the same for the OSR reports, so findings reports, it's 3,000, and everything looks smoothly, and we've sent notifications to every subscriber, which means that our functionality end-to-end looks quite well. But of course, sometimes if you see such kind of a drop downs in your SLA, this means something is not really working as expected. So maybe the workload is not enough, and you have to see where the problem is. So this is where once again, we may become a really more technical or lean into the technical type of metrics. So because we suffered some exceptions, we noticed last Friday that it is related to one of our data centers, so we should download the workloads there and just enable them in the other data center. So this is why in here right now you see no data, and you can see only 16 workers that run in this data center and how much memory they consume. So this can be captured either through what we instrumented or through the metrics that PCF itself emits in Wavefront. So there are no deployments that happens, and a number of rules that were executed. So each report is composed from a lot of rules. You can see how much that is, and it happens really on a constant basis. We try to really balance, so you don't want spikes in this, right? So you have to, when you schedule these reports, you have to distribute them over the SLA period itself. So you don't have any spikes because these spikes comes down the stack and loads everything. So you can see that the total customers are 5.5 thousand, and you can see that 15 customers does not have recent enough inventory report right now, and 16 without findings report. So what is the reason? I'm not going to drill down right now. Somebody else is going to do this for me. So CPU utilization, memory utilization. Okay, let's see the count of the busy workers. So are we sure 16 workers are enough for us? Okay, we see that we are quite loaded right now. Okay, for this period of couple of hours, so this is the last 6 hours. And in here they become silent, so there was nothing in the queue, that's good. And then something was created, good. So going down, the piece of code that does this analysis really goes to its store, but the idea is that you have to go to the store once and cache it somewhere where it's really fast for reusing this data. So what we've captured here, and these are metrics that are instrumented by ourselves. They're not, you don't gain them automatically. This is where the developer is responsible to be able to trace and see how its application behave and be able to improve it and all of that. So in here you can see how much time it takes to, in here there was a, so what is latency? Latency means that you have put something in the queue and at some point this was picked up from the queue and the work started. So the delay here was 1 hour. Okay, that's maybe good, that's maybe bad, I cannot tell right now. And the actual computation, in here you can see how long it takes to do the actual computation. And you can see all the workers and all of that. So this is for the findings, the same for inventory type reports. And let's see how many basically rules are executed. And you can see that we execute thousands of rules approximately per 5 minutes. So which is good to taking into account that we are just with 16 workers. And how many of these rules end up with an error. So our error rate is low, and what is the error rate, of course, is subject to optimization. So you have to be able to retry, or this is part of your business logic. What happens? Does this report meet the quality criteria if just a single rule out of 300 failed? Okay, or how are you going to retry just this one? Is it due to not being able to fetch data from the store? Is it some other kind of exception that happened, or it's basically the script is corrupted in a way? So in memory cache, as I said, you can see that how, if we, for example, ask for a property for a virtual machine inside the customer environment, it takes 64 milliseconds. In here depends how big the data is and what you have asked for the virtual machines. This might be quite huge data. In fact, especially when it comes to host and all the hardware beneath, etc. So you can see that going to the store, it's in memory, this is Redis behind the scenes. So Redis is fast, and you can see that some of those takes really 5 milliseconds operations. It's really fast, even less below millisecond. And when it comes to our store, you can see that going to the store is expensive. And right now in our architecture, this store is outside of our data centers. It's accessed through API that facilitates a store, that facilitates the actual store. So sometimes it behaves slowly, and it is another team that is responsible, so we should be able to go to them and tell them, okay, your SLA degrades, so folks, please check what's happening, help us to restore to normal. And you can see how this looks into counts. So yeah, counts looks good. So we are going to the store 82 times in this particular moment of time just to fetch for data store type of data. And in here we do really a lot, thousands of 3 million operations for a virtual machine from our in-memory caches to do some type of computation. And in here you can see the RabbitMQ, how it looks like. So on the functional chart you saw that we've created reports and we pop the tasks and we compute the report. So this is how the queue looks like. So in here it gradually come to 400 type of reports that has to be computed, and it was consumed within around, I don't know, really few hours it was consumed. So that's all I can share right now with you. And let's jump to what are our basically best practices that we learned through the last year and a half. Really, you should lean on a lot of metrics that can help you and save you and lead you towards the right direction into the decisions you are going to make, the technologies you are going to choose. Is this really the right thing you did with your services? And also be able to measure your SLA. These all should come from metrics, and your application should really meet that. You should not have only technical metrics, you should also have some kind of functional metrics that measure the functionality end to end. It's not one service, it's not distributed trace. Distributed trace really can show just one of the traces among the functionality itself, but you have to have some kind of a metrics that captures this. Developers and SREs, to those of you who have SRE teams and SRE helps them, you should be looking at the same data, have the same understanding of the data as to be able to really fast jump to resolutions. And you should be really doing real-time monitoring of your services post-deployment. This is really important because no matter how much you test, unit test, integrate test, end-to-end test on any environment that is not production, still something may go wrong in production. So you should use alerting, you should establish a baseline for your metrics, and you should do, because we own the quality, we are doing, when we do deployment, we do post-monitoring. We also, as a capture a lot of PCF alerts and PCF events in addition to when we deploy, when we do a deployment via our CI/CD. So that's all I can share with you right now, and that's it.
Thank you. Thank you, Hristo. That was some geeking out there with code and everything. I love it. I totally love it. I mean, this goes to show that monitoring an application like your application, it's actually not as simple as you may think. There is a lot of things you need to think about, right? You need to think about having these business metrics and being able to correlate them to technical things that go on in both the application and the platform, as well as the infrastructure, right? So I thought it was really interesting that you went through really soup to nuts end to end there. Before I open up for Q&A, I would not be doing my job as the chief evangelist for Wavefront if I didn't say this. If you want to play around with something that you can do all these things with, you can actually sign up for a trial, and you get the pleasure of burning some of our AWS money there, so that's wonderful, right? And what you can do, you can actually hook up your own application and your own PCF to it, and you'll see it live. So it's a software as a service kind of thing. So if you want something to play with, check that out. With that, we have about a couple of minutes for questions. Is any questions from anybody? Yes.
So what kind of detail do you get from, so this is on an on-prem infrastructure using vSphere.
Yeah.
What if you are in the cloud? What kind of detail do you get to that? Or do you get to just basically create the
So it's you get similar level of detail, right? I mean, you're not going to get the hardware detail because AWS doesn't show you that, but you get down to the instances. So you get down to the instance level, right? You basically get as deep as your cloud provider allows you to go, right? So there's one plugin for vSphere, and there's one plugin for AWS and all the others. So that's how that works. Anybody else?
Yeah, actually we have like 50 to 60 different AWS integration, depends what you use. So pretty hefty.
Yeah, it's pretty cool when you hook that up and you just put your AWS information in. It kind of, wow, you're like, oh, I had Lambdas. I had no idea. That can be a revelation sometimes. Anybody else? Yes, sir.
Is this like an agent install?
So it is for Pivotal Platform, it's a nozzle. Very simple, tiny little thing that you just do. It's an either tile or you CF push it, and you fill out like the host you want to send it to, but that's about it, right? And then typically best practice is that you have a proxy on site that kind of concentrates all the traffic. You can send it directly from your nozzle. I tend to like the proxy idea because the proxy will, if you lose connection to the cloud, it will cache it and good things like that.
Sorry to interrupt. So Micrometer.io also provides the capability for your applications to send metrics directly or through proxy itself.
Yeah.
So you can configure the beans to use a proxy.
And you can use StatsD for instrumentation or Drop Wizard, Telegraph. It's pretty light, and if you use some APM and you want to import that data as well, you can do that. You can do any combination. So.
Anybody else? Yes, sir.
Question for the guy that was demoing.
Yep.
So for the 9 months or so you're doing this, you talked about collecting PCF alerts.
Yep.
How much of that time did you spend like trying to weed out what was the actual useful alert versus like noise alert?
Okay, so we don't have that much of alerts. Maybe the reason is because our ITs are doing a good job with infra itself. But it doesn't take too much because when you set up an alert, you really set up the alert in a certain context. It may be broad context, for example, the number of exceptions went high, but it is just an exception. There is this kind of alert may not tell you what the exception is, so you have to manually go and check what the exception is. And we don't use just these tools. We use one additional tool, which is aggregating exceptions. It's called Sentry. So we use this if we want to look exceptionally on this, but typically when we set up an alerts, it might be the store response really high. This is why I said you have to establish a baseline. So if you know your baseline, then you can adjust your alert. And yeah, it happens, and it happens, intermittent failures happens. So, but this is why there is an SRE team, so this is not being escalated right now to engineering.
So we're actually out of time. We have another speaker coming in, and they told us to be respectful to them. However, all three of us are going to be out there for the next 15 minutes or so. And if you don't have time to see us there, we got Twitter handles there. Top one is me. Middle one is her, and
The most
is me.
important.
Wow, you don't even have a Twitter. Come on.
No Facebook, no Twitter. That's not me.
All right. Anyway, so if you want to get hold of us that way, you can. Otherwise, we'll be out there.
And
Thank you very much for coming.
Thank you.
Thank you.